Okay, this is an example from 7.6, which is solving rational expressions, or solving rational equations, actually. This is an equation because it has an equal sign, and now we're actually going to solve this equation. Now, there are actually two ways of solving rational equations. One approach is you can go about this the way you did section 7.4 and come up with a least common denominator, add these two fractions together, and then once these two fractions are one single fraction, then you can cross multiply with the answer and try to solve for x. But I think there is a better way. Okay, and this better approach is, instead of working with common denominators, how about we just get rid of all of our denominators? Because who really likes to work with fractions? So the best thing to do is to get rid of our denominators. How do we get rid of our denominators? So what we're going to do is we're going to get rid of denominators. If you can read this. I don't know if you can read that or not. How are we going to get rid of our denominators? We're going to do this by multiply every term by the LCD. Okay? Okay, so therefore we have to get the LCD. And before we get the LCD, I think we have to do some factoring. X plus 7, this here is done. X minus 2 can't be factored, but the x squared plus 5x minus 14 does have to be factored. Now, look for GCFs first. There is nothing common in all three of these except for 1. We don't factor out 1. So then it looks like a trinomial factoring problem. That's what we call it in math. A lot of students call it reverse FOIL. It is a trinomial factoring, reverse FOIL, as some people call it. To get x squared, we need x. And then what we're trying to do is we're trying to find two numbers that add to be 5 and that multiply to be negative 14. And then you just have to come up with that. Two numbers that add to be 5 and multiply to be negative 14. If you figure that out, that's going to be plus 7 and minus 2. If you notice, do you notice that it matches these two that I have highlighted? Well, that happens in these problems because they don't want to make the LCD too extreme to make the solving hard. These problems for you are set up in a way where a lot of the common factors match, so the LCD isn't that hard. Okay, so let's get the LCD. If you look here, we have x plus 7, x plus 7, x minus 2, and x minus 2. I don't think it's surprising that we have one x plus 7. There's one here, none here. So x plus 7, and there's going to be an x minus 2 because there's none here, and one here. So 1x plus 7, 1x minus 2 makes up the common denominator. So now what we're going to do is we're going to give us some room. I'm going to recopy, but this time I'm going to put x plus 7, x minus 2 here. And this equals x over x minus 2. Okay, now we need to multiply by by the missing factors to get the common denominator. Notice I'm going to put the x minus 5 here in parentheses. That should be in parentheses, and that should be in parentheses. Try to put binomials, two terms being added or subtracted, in parentheses. Okay, so now we need to get what we're going to do now is, instead of getting the LCD, we're going to multiply the LCD. If you could read this, get rid of denominators, multiply every term by the LCD. So what we're going to do is, that kind of moved on me. So I'm going to erase it. Is we're going to multiply every term by the LCD. So we're going to multiply this by x plus 7, x minus 2. We're going to multiply this by x plus 7, x minus 2. And we're going to multiply this by x plus 7, x minus 2. So if you notice, I'm going to multiply every single fraction by the LCD. This is what you do when you have problems that have equal signs in them. The problems from 7.6, solving rational equations. Okay, so we're going to multiply everything by the LCD. Now, why do we multiply by the LCD? Well, we multiply by the LCD so we start canceling. So if you notice in this first fraction, you have an x plus 7 on the top and an x plus 7 on the bottom. They're going to cancel. Okay, and then here we have an x minus 2 on top and an x minus 2 on the bottom. They cancel. Okay? Here we have an x minus 2 on the bottom and an x minus 2 on top. They cancel. And then you write down what's left. Okay? So once you do the canceling, you write down what's left. What's left is we have an x minus 5 times an x minus 2, nothing in the denominator. By the way, I forgot to cancel these as well. You're probably yelling at me, why didn't you cancel the x plus 7s? They cancel too. Minus x, everything else canceled here, equals x times x plus 7. And now what you're left with is a regular solving problem without fractions in it. So now let's solve this. So to solve this, of course, we need to do a little special product here, distributive property. X times x is x squared. X times negative 2 is negative 2x. Negative 5 times x is negative 5x. Negative 5 times negative 2 is positive 10. Minus x equals, this side, distributive property, x squared plus 7x. Okay, and now we have like terms. So we have x squared minus 7x plus 10. Oops, missed this one too. Minus 8x plus 10. 8x, negative 2, negative 7, minus 1. Minus 2x, minus 5x, minus x. So x squared minus 8x plus 10 equals x squared plus 7x. We're going to move our x squareds to the left side. These go away, and notice these go away too. So they both cancel. So we're left with negative 8x plus 10 equals 7x. We add 8x to both sides. Those cancel. And we're left with 10 equals 15x. Divide by 15. And we get 10/15, but that needs to be reduced. Divide by 2, or divide by 5, and that would be 2/3. Now, we're not done yet. I'll give you some time to look at that. So that's the solution to the problem, 2/3. It might be a solution to the problem. We need to go back up to the original problem, and you have to remember that you can never, ever, ever, ever divide by 0. Okay, so if you notice here, if x is equal to negative 7, you would get division by 0. So negative 7 is not in the domain of this problem. X cannot equal negative 7. Also, if you notice, x cannot equal 2 because 2 minus 2 is 0 here, and of course 2 minus 2 is 0 here. That would make the middle one. So if your answer became negative 7 or 2, this problem would have no solution. There would be no answer to this problem. But it's not. Our answer is not negative 7 or 2. Our answer is 2/3. So that's the solution. If you want to see some more examples, check out the link in Canvas to Khan Academy. Thank you very much.